Hey everyone, it's Elisa. In this lesson, we are going to practice solving some one-step equations. And by solving, our goal is to take wherever the variable is and to isolate it. So if we have a variable of a on the left-hand side, we want to be able to isolate it so that at the very end, so our goal at the end of this is that we end up with something that looks like a is equal to some sort of number. That's what we're trying to figure out. Okay, so right now, something's happening to it. There's an addition of 2. I will grab my highlighter. So I notice that beside the a, there's a plus 2 that is happening. This plus 2 is stopping my a from being all alone. So I need to get rid of it. In order for us to get rid of it, we need to apply one of the algebraic principles. We could add something, we could subtract something, we could multiply, or we could divide something to the left and the right side of this equation. One of those things, we could do any of those things and maintain equality, but one of those things is going to really help us out. So let's say we were to add 2 to both sides of this equation. So if I started off with a plus 2 is equivalent to 15. That's our original statement. And you know what? Let's say that I want to add 2 to the left and to the right-hand side. Has this helped me? Well, simplifying, on the right-hand side, 15 plus 2, that's 17. On the left-hand side, these 2 plus 2, that's 4. So that gets me a plus 4 is equal to 17. Am I any closer to having a by itself, having it isolated? No. In fact, I just created more work for myself. Now, beside the a, I have an addition of 4 that is happening. So what I did was okay. When I say like add 2 to the left-hand side and add 2 to the right-hand side, I've maintained equality. I've performed the same action on the left as I did on the right. But it just wasn't the best thing for me to do in order to isolate for a. Okay, so I am going to erase all this stuff and do another plan. So plus 2 is not the solution. We need to do something else. So we're not going to add 2 to the left and the right-hand side. What is something else we can do that we can get rid of a plus 2? Let's try subtract 2. So if we were to subtract 2 on the left and subtract 2 on the right, does this help us with our plus 2 on the left-hand side? Well, for sure it does. Now I'm left with plus 2 minus 2. So if I have positive 2 and I subtract 2, that's 0. That leaves me with nothing. So a plus 0 is equal to 15 minus 2, which is 13. A plus 0, that could be simplified to just a. I don't need to show the plus 0. So a is equal to 13. Can I check if I've done this correctly? Have we solved for the value of a? For sure we can. We can start with their original equation. So as a check, you can start off with your equation. A plus 2 is equal to 15. And then for the value of a, let's grab a highlighter. We said that a has a value of 13. So wherever I see a, I'm going to substitute that into our formula. So it would look something like 13 plus 2, is that equal to 15? Well, 13 plus 2 is 15, which is the same thing as 15, so we have solved this equation correctly. Awesome. Let's move on to another one-step equation. Here we have 8c is equal to 40. So 8c, another way of saying 8c is the same thing as saying 8 multiplied by c is equivalent to 40. The first and the second line are the same thing. Now our goal, again, we need to isolate for the variable c. We want to get rid of that 8 times, the factor of 8. So what should we be doing? Should we add 8? Should we subtract 8? Should we multiply another 8? Or should we divide 8? What will help us get rid of the factor of 8? Well, let's divide by 8. When we divide the left-hand side and the right-hand side both by 8, what happens? Well, 8 divided by 8, that reduces and gives us 1 times c. And then on the right, we get 40 divided by 8, which is 5. 1 times c is the same thing as just saying 1c, which is 5, or just c. When the coefficient of a variable is 1, usually it isn't written, so we can say c is equivalent to 5. Let's check. So we can do a check. We want to show that 8 multiplied by c is equivalent to 40. So I'm going to take our value of c and substitute it in the equation. So 8 multiplied by 5, is that equivalent to 40? 8 times 5 is 40. So these two things are equivalent to each other. Let's try another. C minus 2/5 is equal to 3/10. Again, we want to isolate c. We want it to be the only thing on the left-hand side of this equation. Right now, there is a subtract 2/5 that's in the way. So we got to think, what is the opposite? So to get rid of that, we need to find the opposite operation. So what is the opposite of subtracting something? Well, the opposite of subtracting that thing would be adding it. So we'll start off with c minus 2/5 plus 2/5 is equal to 3/10 plus 2/5. I'm being careful to always include an equal sign. Well, I always want to keep that equal sign between my left and the right-hand side of my equation. On the right-hand side, c minus 2/5 plus 2/5, that ends up with being 0. So c plus 0 is equal to. On the right-hand side, I need common denominators to add those fractions. So I'm going to go ahead and do some, make an equivalent fraction here. So times 2 times 2. I'm choosing times 2 so that my denominators could both be 10. So now the fractions on the right would look like 3/10 plus 4/10. On the left-hand side, c plus 0 is the same thing as c. So c is equal to add my fractions, I'm going to add my numerators. 3 plus 4 is 7. So we end up with a c value of 7/10. Again, the equal sign, you got one equal sign per line, and it's always between two expressions. Awesome. Let's try another. So in this question, we have z over 4 is equal to -6. This over 4 is implying an operation. So any fraction, that little line right there, is telling us to divide. So this is a division that's happening between the z and the 4. So to think about our opposites, the opposite of dividing by 4 will undo this operation. That's multiplication. So we will have z over 4 equals -6. And now we will multiply the left and the right-hand side by 4 and 4. On the left, I'm going to do one more thing. I'm going to write this 4 with the denominator of 1 simply because the z over 4 is written as a fraction. So if I write this as a fraction, it's helpful for when I multiply. Okay, so let's simplify. Z times 4 is 4z divided by 4 times 1. That is 4. On the right-hand side, negative 6 times 4 is negative 24. On the left, we can do some reducing. So you have a 4 in the numerator, a 4 in the denominator. So can a 4 be divided by 4? For sure, 4 divided by 4 is 1. So 1z is equal to negative 24. 1z, or 1 times z, is negative 24. Or we could just say z is equal to negative 24.